We consider now a particle whose static equilibrium position is determined by the force which acts on it. Consider a system in a static equilibrium position. Any assumed and arbitrary small displacement delta r away from this natural position and consistent with the system constraint is called a virtual displacement. The term virtual is used to indicate that displacement does not really exist, but only is assumed to exist so that we may compare various possible equilibrium positions to determine the correct one. The work done by any force F acting on the particle during the virtual displacement is called the virtual work. The work done by any force F acting on the particle during the virtual displacement delta R is called virtual work. Delta U F delta R or delta U F delta S cosinus alpha, where alpha is the angle between F and delta R and delta is the magnitude of delta R. The difference between delta R and ER delta R and delta S and The difference between delta R and the dr is that dr refers to an actual infinitesimal change, where delta R refers to an infinitesimal virtual and cannot be integrated. Mathematically, both quantities are first-order differential. A virtual displacement may also be a rotation delta theta of a body according to the figure shown in the previous section. We may regard the force F or tuple M as remaining constant during an infinitesimal virtual displacement if we account for any change in F or M during the infinitesimal motion. Higher order terms will result which disappear in the limit. This consideration is the same mathematically as that which permits us to neglect the product dx dy, for example, when writing the in the mathematical higher order elimination, for example, dA plus y plus dx multiplied to dy, for example, y multiplied to dx y dx plus dx dy. In our calculation, we eliminate higher order infinitesimal multiplication. The next section is equilibrium. According to this chapter,